Let's take a look at the Physical Sciences November 2024 paper 1. Question number 1, multiple choice. Which of the following indicates the number of pulses per second? So this is testing a definition. Remember, period is the time taken for one wave. So time for one wave. And frequency is the number of waves per second. So the answer that we're looking for here is C. Question 1.2. The velocity time graph for a car traveling along a straight horizontal surface is shown below. North is taken as positive. Which of the following combinations will be correct for the motion of the car after 20 seconds? So we are trying to examine this motion here. So remember, with velocity, since velocity is a vector, the negative sign just tells us the direction. So let's imagine a value here. Let's suppose that that is negative 10. Now, if they say north is taken as positive, this means that this direction is north and that direction is south. So at 20 seconds, the car is traveling, in this example, 10 meters per second south. And it is then slowing down to a stop. So let's look at the options. We have acceleration being positive. We have direction of motion north. We have B positive, acceleration, and direction of motion south. So because we've already interpreted the graph, we know that direction of motion in this section is going to be south. So A and C are removed. Now it's just a matter of figuring out the acceleration. And to figure out the acceleration, we look at the gradient. Remember, the gradient of a velocity time graph tells us the acceleration. Now, the slope, you can look at the shape of that line, that is a positive slope. And since the slope is positive, it means that the acceleration will be positive. So the answer that we're going to go with here is B. Question 1.3. Which statement explains why a glass rod becomes positively charged when rubbed with a woolen cloth? So 1.3, we have a glass rod and we have a cloth. So the rod is positively charged and they want us to explain which statement is correct. So protons are transferred. So immediately we will eliminate any option that has protons in it, because with electrostatics, we do not state that protons are transferred. So we will remove A and we will remove B. Option C says electrons are transferred. Okay, so that first part is correct. From the glass rod to the woolen cloth. So that statement is actually correct, because if electrons are going this way, it means that the rod is going to be deficient in electrons, and that means it's going to have a positive charge. So simply put, when something loses electrons, like we are saying the glass rod did, it's going to have a positive charge. Question 1.4, so the answer here is C. Question 1.4, an object is thrown from the top of a building with velocity with velocity V and kinetic energy E. It reaches the ground with a velocity of 2V. Which one of the following is the object's kinetic energy just before it strikes the ground? Okay, so here we can say that EK is equal to half mv squared. Now before it hits the ground, it has a velocity of 2v. So 2v all squared. So we can simplify. We're going to have half m times 4v squared. We can then move that 4 to the front. We're going to have 4 half mv squared, which is 4e. So the answer is going to be B. Let's take a look at question 1.5. A battery is connected to 3 identical resistors in different combinations. Which combination represented in the circuit diagram below will result in the ammeter having the largest reading? Now, in all 4 cases, the ammeter is reading the total current. So what we need to do here is we need to identify the option that's going to give us the lowest resistance. Remember, resistance is inversely proportional to current. So if we want the highest current, we must choose the one that's going to give us the lowest resistance. So series combinations will not give us a low resistance, so B is out. You have A and C. C will also be out because you have something in series. R3 is in series. You then have A and D as the last 2 options. Now, the answer here is going to be D. And that's because each resistor is in its own parallel branch, which is going to decrease the resistance significantly compared to A. So A would be eliminated because R1 and R2 are in series. And they are in parallel, or that branch is in parallel with R3. Whereas D, they're all in their own individual branches. Let's take a look at question number 2. Question number 2 is a waves question. The propagation of radiation X in air is represented by the transverse wave pattern below. Question 2.1, calculate the frequency of the wave. So 2.1, we can say that frequency is equal to number of waves divided by time. So we've got the time for those number of waves. They tell us that the time is 3,57 times 10 to the negative 12. Now we just need to count how many waves there are. So from the beginning to here, that's going to be 1 wave. Then that's going to be the second wave, and that's going to be half a wave. So we have 2.5 waves. So 2,5 divided by that time, and that's going to give us 7 times 10 to the power 11 hertz. Question 2.2, write down the speed of the wave. So this is radiation, and all EM radiation moves at a constant speed c, and that's going to equal 3 times 10 to the power 8 meters per second. Question 2.3, the table below shows the data for different types of radiation in order of decreasing wavelength. Question 2.3.1, by means of a suitable calculation, identify the type of radiation represented by X. So X is here, radiation X. So we can use a formula, C is equal to F times lambda. And we can solve for lambda and then compare it using this table. So 3 times 10 to the power 8 is equal to 7 times 10 to the power 11 multiplied by lambda. Lambda is thus equal to 4,29 times 10 to the negative 4 meters. Now when we compare that, that's going to fit in right in our infrared range. So X is infrared. Let's take a look at question 2.3.2. Determine the energy of this. So E is equal to HF. H is Planck's constant, 6,63 times 10 to the negative 34, multiplied by the frequency, 7 times 10 to the power 11, and that gives us 4,64 times 10 to the power negative 22 joules. Let's take a look at question 3. S and T are 2 points on a longitudinal wave pattern traveling at 2 meters per second east. The distance between 4 consecutive compressions is 1.2 meters. Question 3.1.2 reads, calculate the frequency of the wave. So to calculate the frequency, we can say that, they tell us 4 consecutive waves. So 4 waves is equal to 1.2 meters. That means one wave is going to equal 1.2 divided by, important, I misread this, 4 consecutive compressions. So 4 consecutive compressions is not 4 waves. Let me just explain this part. So, smaller eraser. So if we have a compression, so let's say that's 1 compression, 2 compressions, 3 compressions, 4 compressions. The distance, so 4 consecutive compressions, is 1.2 meters. But that's not 4 waves. This is 1 wave, that's 2 waves, and that's 3 waves. So it's actually 3 waves equals 1.2 meters. That means 1 wave is equal to 1.2 divided by 3, which is 0.4 meters. Now that we know the wavelength, we can calculate the frequency. We can say that speed is equal to f times lambda. It's moving at 2 meters per second, so 2 is equal to f times 0.4. That means f is equal to 5 hertz. Question 3.1.3, determine the time taken for the wave to move from point S to point T. Now, S and T, so that's going to be 1 wave, and that's going to be 2 waves. So if we know the frequency, we can calculate the period. So 3.1.3, period is equal to 1 over frequency. So that's 1 over, frequency was 5. So 1 over 5, and that's equal to 0.2 seconds. Now, this is the time taken for 1 wave. So if we want to calculate the time from S to T, that's going to be 2 waves. So from S to T, that's going to be 0.2 times 2, which is 0.4 seconds. Question 3.2. The alarm of a stationary ambulance emits a sound wave which is detected by Sam and James. Sam stands at an unknown distance x meters due east of the ambulance and hears the sound after 0.6 seconds. James stands 50 meters due east of Sam and hears the sound after 0.75 seconds. Question 3.2.1. Calculate the speed of the sound wave. So 3.2.1, we can say that speed is equal to distance divided by time. So we don't know the speed, but we know the distance between Sam and James. So that's going to be 50 meters. Now the time, since we are using the distance between Sam and James, we need to consider the time between Sam and James. If the time at this point is 0.6 and the time at this point is 0.75, then the time between them is going to be 0.75 minus 0.6. And that's going to give us an answer of 333.33 meters per second. There is another way, but this is the simplest way. Question 3.2.2 says, determine x, the distance between Sam and the ambulance. Now here we can simply say speed is equal to distance divided by time. We've calculated the speed as 333.33, and that's equal to the distance x divided by the time between, or the time it takes to go from the ambulance to Sam is 0.6. So divided by 0.6, that means distance is equal to 200 meters. Question number 4. A metal sphere P, which was initially neutral, is given a charge of 8 times 10 to the negative 9 coulombs. Question 4.1, were electrons added to or removed? So because it has a positive charge, it means that electrons were removed from the sphere. Question 4.2 says, determine the number of electrons that were added or removed. So here we are going to say that Q is equal to N times QE. The current charge is 8 times 10 to the power negative 9. That's equal to N, which is what we want, multiplied by 1,6 times 10 to the negative 19. That is a constant. That means N is equal to 5 times 10 to the power 10 electrons. They then tell us that sphere P is now suspended from a wooden beam. An identical sphere R carrying a charge of minus 12 times 10 to the negative 9 is brought into contact, and it's basically shown in the diagram. Question 4.3 says, determine the charge on sphere R after it touches and separates from sphere P. So here we're going to use the formula Q nu is equal to Q1 plus Q2 divided by 2. So sphere P had a charge of 5 times 10 to the power, not 5 times 10. It had a charge of 8 times 10 to the power minus 9, plus the other sphere has a charge of minus 12 times 10 to the power minus 9, and then divided by 2. Now, because they are both times 10 to the power minus 9, you can omit it and then bring it back, but this is a safer option, just to write it in. So the answer you get here is minus 2 times 10 to the power minus 9 coulombs. Question 4.4, will the spheres attract or repel each other after contact? So they are going to repel each other. And the reason is, once they come into contact, they are now going to have the same charge. So after contact, they have the same charge. And like charges will repel. Question number 5. A battery with an EMF of 22 volts is connected to 3 resistors and an electrical device. The connecting wires and the battery have negligible resistance. The voltmeter reads 8 volts. Okay. Define current, that's okay. Question 5.2, calculate the reading on ammeter A1. So they want to know what is the reading on this ammeter that's going through that branch. So we can use the formula I is equal to V over R. So what is the voltage that is across, or what is the voltage for the 4 ohm resistor? Well, they tell us it's 8. And what is the resistance of the 4 ohm resistor? It's 4. So the current going through that branch is going to be 2 amperes. Question 5.3.1. 3000 joules of energy is transferred in the electrical device in 1 minute. So W is 3000. Time is 1 minute, which is 60 seconds. And the question is asking us to calculate the charge traveling through the electrical device in 1 minute. So what we can calculate, there are a few formulas here that we could use. We could use V is equal to W divided by Q. And they want the charge. So they want Q. We know W, right? So what we then need to work out is the voltage for this device. And it's worth 5 marks, so it means that we're probably going to have to do multiple calculations here. So The first step would be to work out what is the voltage that is being used in the parallel combination. So we can work that out using the formula V is equal to I times R. Now, if we're focusing on this pink branch, we know the current in that branch. The current is 2. We worked it out. And what we don't know is the voltage that is being used by this 2 ohm resistor. So let's multiply that by the resistance 2, and that gives us 4 volts. So this is using 4 volts, this is using 8 volts, which means that this pink branch in total is using 8 plus 4, which is 12 volts. Now, because voltage in parallel is the same, it means that this branch is also going to use 12 volts. But when we're working in parallel, we only use it once. So it means that if the battery is giving 22 volts, and again, we only count the parallel branch once, this section is using 12 volts, it means that the balance must be what's being used by the device. So the device is going to use 22 minus 12, which is 10 volts. So the voltage for the device is going to equal 22 minus 12, which is 10 volts. So now that we know the voltage and we know the W, we can work out Q. We can say that 10 is equal to 3,000 divided by Q. That means Q is equal to 3,000 divided by 10, which is 300 coulombs. So that's our answer. Question 5.3.2, calculate the reading on ammeter A2. So A2 is reading the total current. If you look at where it is positioned right here, just after the battery. So we can use the formula. What we can do is we can work out, we don't know what R1 is. Okay, we can use this. Since we know the charge that is going through the device, we can then, and we know the voltage, we can work out the current. So we can use the formula Q is equal to I times T. So remember, this is for the device. And we worked out the Q value. The Q value is 300. That's equal to the current. Now remember, the current that's going through the device is the total current. Right? So the current, which is what we want, multiplied by, they told us that this is for 1 minute or 60 seconds. So multiplied by 60. So the current is going to equal 300 divided by 60, which is 5 amperes. We could work it out a different way. We could say that W is equal to VI delta T, though it is the same thing. Here we'll have the 3000 because that was given to us. The voltage we calculated was 10. The current is I, what we want, and that's 60. And then you calculate it and you still get the same answer. You get I is equal to 5. So either one is fine. The reason why we couldn't use V is equal to I times R is because we don't know the resistance of this. We don't know the resistance of R1. Now moving on, they tell us the switch is now opened. Will the current through the device increase, decrease, or remain the same? And give a reason for the answer. So this switch is opened. So if that switch is open, it means that no current is going to flow through R1. So it's basically saying that that's going to be my new circuit, that blue section, whatever is highlighted in blue. Now, what are we essentially doing? We are removing a resistor in parallel. Now, when you remove a resistor in parallel, the total resistance increases. Since voltage is the same, and you know the formula V is equal to I times R, if resistance increases when voltage is the same, it means that current must decrease. Let's take a look at question number 6. Peter and Jim are both on the final lap of an 800-meter race in a swimming pool of length 50 meters. When Jim is at the pool wall 1, Peter is 20 meters ahead of Jim. Both swimmers are moving eastward to finish the race at pool wall 2. Okay, so we've been given a diagram here. Question 6.1, write down the position of Peter relative to the finish line when Jim is at pool wall 1. So they want to know, write down the position of Peter. So where is Peter? Let's get the pen again. Don't know why the pen is not working. Give me 1 second. Okay, so when they say write down the position of Peter relative to the finish line, what they are actually saying is put yourself at the finish line. So if you put yourself at the finish line, where is Peter relative to that line? So there's my finish line. Peter is firstly west of the finish line. So 6.1, Peter is west of the finish line. But how many meters? So Peter is here. If that is 20 meters and the whole length of the pool is 50, that means he is 30 meters west of the finish line. They then tell us that Peter swims at an average velocity of 1.2 meters per second east. Calculate the time taken for Peter to reach the finish line from his current position. So question 6.2, we can use the formula V is equal to delta x divided by delta t. So it's 1.2, and that's equal to, well, he's traveling 30 meters and divided by the time. So divided by delta t. So delta t is going to equal 30 divided by 1,2, which is 25 seconds. Question 6.3, calculate the average speed at which Jim needs to swim in order to finish the race 0.5 seconds ahead of Peter. So what this is basically saying then is that if Peter takes 25 seconds to reach the end, that means Jim needs to cover that distance. Well, Jim is here, so Jim needs to swim the 50 meters in 25 minus 0.5, which is 24.5. So Jim needs to swim 50 meters in 24.5 seconds in order to win, or that's the restriction. So speed is equal to distance divided by time. Jim needs to swim 50 meters, and he needs to swim it in 24.5 seconds, and that's going to tell us that he needs to swim at 2.04 meters per second. So quite a bit faster. Question number 7. Car X, starting from rest at point A, accelerates at 4 meters per second, squared for 5 seconds along a straight horizontal road traveling eastward. After 5 seconds, it continues further at a constant velocity. At the same instant, car X starts to move. Car Y moves past point B on the same road in a westerly direction at an unknown constant velocity. Points A and B are 490 meters apart. Question 7.2, calculate the velocity that car X reaches after 5 seconds. So let's look at the information that we know. We know Vi is equal to 0, right? So it says, and the reason why we know that is because it says it starts from rest. Then we know the acceleration. The acceleration is going to be 4. And they tell us the time. Time is 5. So if you know 3 things, you can use any equation of motion. Well, there is an equation of motion to use to calculate the thing that you want. So in this case, we'll use Vf is equal to Vi plus A delta t. Vi is 0 plus 4 times 5, and that's equal to 20 meters per second east. because they tell us that he is moving east. Question 7.3.1. Both cars passed each other after 12 seconds. So 7.3.1 says determine the distance covered by car X in 12 seconds. Now, car X is not traveling at a constant velocity, right? So car X is actually accelerating and then it's moving at a constant velocity. So we're going to have to use two different equations of motion. So we'll use the first equation of motion for the first 5 seconds. So delta x is equal to vi delta t plus half a delta t squared. So 0 plus half into 4 times 5 squared, and that gives us an answer of 50 meters. Then from 5 seconds to 12 seconds, he's moving at a constant velocity. So we can use the formula delta x is equal to v times delta t. So the velocity is 20. We worked it out. At 5 seconds is moving at 20 meters per second, and multiplied by from 5 to 12 is how many seconds? So you have 6, 7, 8, 9, 10, 11, 12. It's actually 7 seconds. So 20 times 7 is equal to 140 meters. Now remember, this formula can be used only when there is constant velocity. So now the total distance for car X is going to be 140 plus 50, which is equal to 190 meters. Question 7.3.2 says, calculate the velocity of car Y. Now, car Y is traveling at a, well, we know at a constant velocity, they tell us. So car Y moves past point B at the same road in a westerly direction at an unknown constant velocity. So we know that the cars are 490 meters apart. So that means that car B traveled a distance of 490 minus 190, which is equal to 300. So car Y traveled 300 meters. Then we can use the formula V is equal to delta x over delta t. And again, we can use this because it's constant velocity. So delta x is 300 divided by delta t. Well, they tell us that the cars pass each other after 12 seconds. So delta t is 12. And that gives us an answer of 25 meters per second. And it is moving westerly. So the answer, 25 meters per second west. Question 7.4, on the same set of axes, sketch the velocity time graph for both car X and car Y until they pass each other. Label each graph. So we're going to have a velocity time graph like so. I'm going to choose east as positive. That means this section here is going to be west, and this section here is going to be east. Now this is a velocity time graph, and that's going to be time. Now, car A starts from rest, so the velocity is 0, and it accelerates for 5 seconds. And we know the velocity at 5 seconds, we worked it out to be 20. Then, until 12 seconds, it moves at a constant velocity. But car Y, so this is car X, but car Y on the other hand is traveling westerly, and it's traveling at minus 25. So that's going to be a straight line like so, constant velocity. Let's now take a look at question number 8. A boy skates along the frictionless ramp shown below. The The boy starts at point X, 2 meters above the ground at a velocity of 1 meter per second. The combined mass of the boy and the skateboard is 60 kilograms. Question 8.1. Calculate the mechanical energy of the boy and his skateboard at point X. Okay, so remember mechanical energy, EM, is equal to the potential energy plus the kinetic energy. So the potential energy is going to be mass times gravity times height. So 60 times 9,8, and x is 2 meters above the ground, plus EK is half mv squared, so half of 60, multiplied by the velocity, they tell us is 1, so 1 squared. And that gives us 1206 joules. Question 8.2. Determine the speed of the boy and his skateboard at point Y. So at point Y, we know that the total mechanical energy is going to be the same. So we can say that 1206 is going to equal EP plus EK. Now 1206 is going to equal, the potential energy is going to be 60 times 9,8, and Y is 1.5 meters above the ground, plus half of 60 times V squared. We can then solve for V, and that's going to equal 3,29 meters per second. Question 8.3. Use relevant calculations to show that the skateboard will not be able to reach point Z when starting at 1 meter per second at point X. So it seems more difficult than it actually is. But what we just need to do is we need to work out the potential energy at Z. So assuming this boy had to reach point Z, what potential energy would he need? So we can calculate that. We'll say 60 times 9,8 times 3. And that's equal to 1,764 joules. This value, the potential energy, is more than the mechanical energy that the boy actually has. So the potential energy needed, the 1764, is greater than the mechanical energy of the boy. So because of that reason, the boy is not going to reach that point. And that's the paper. Thanks so much for watching. Don't forget to leave a like, share this video with your friends, and subscribe for more. Bye-bye.